Picture people waiting in an Apple store. Computers, mobile phones. Think about Best Buys, Walmart, electronics, housewares, microwaves, toaster ovens, coffee makers, photocopiers, printers, refrigerators, ovens, air conditioners, solar panels, MP3 players, and even children's toys. Approximately 50 million metric tons of electronic waste is produced globally each year. That's approximately equivalent to the weight of 25 million cars. Of this, 17% is properly recycled. The remaining e-waste is taken directly to landfills. In the United States, e-waste represents only 2% of trash in landfills, but constitutes 70% of the overall toxic waste in landfills. The amount of e-waste is growing 5% annually. Most of Europe and the developed world are seeing similar situations. When possible, some electronics can be refurbished and used by new users. Yet, companies have been found to use techniques such as using proprietary screws or gluing essential parts of a phone or a tablet together, so if the device was opened, the parts would break. These companies copyright or declare proprietary schematics and manuals to keep them out of the public domain. In the United States, so-called right to repair legislation, intended to allow consumers to repair their own devices more easily, has been repeatedly lobbied against by tech companies. In April 2019, a right to repair bill was put forward in California, only to be pulled following lobbying by big tech companies and a trade organization representing these big tech companies. It was reported that the lobbyists met directly with members of California's State Assembly's Privacy and Consumer Protection Committee, which was considering the bill, arguing that the consumers might be at risk of hurting themselves if encouraged to open up their phones and attempt repairs themselves. The sponsor pulled the bill following this corporate intervention. There is substantial economic rationale to recover or refurbish e-waste products. When a reuse opportunity is not identified, e-waste can be processed to reclaim valuable materials within. E-waste typically has multiple types of valuable material, including gold, silver, aluminum, and copper. When processed properly, valuable materials are recovered. Hazardous waste is properly treated, and expensive and potentially damaging mining operations to acquire new raw materials can be avoided. Due to its hazardous components, e-waste has become an important public health and environmental concern in many countries. In developing countries, where inadequate e-waste management infrastructure and informal recycling occurs, the problem is aggravated. Liquid and atmospheric releases of hazardous materials in e-waste end up in bodies of water, groundwater, soil, and air, which could affect directly or indirectly health and environment. Pictures of Guiyu, China, and pictures of Agbogbloshie, Guyana, can be horrifying. In Guiyu, China, about 100,000 workers scavenge e-waste for recoverable materials. Their earnings are 5 times more than they would earn as a farmer or laborer. Unfortunately, approximately 88% of the workers are afflicted with neurological, respiratory, or digestive abnormalities. The local river is poisonous. The local groundwater is undrinkable. The children have 50% more lead in their blood than typical values. The Guiyu scavenging operation is not legal by Chinese standards, but the venture is so profitable that it continues to thrive. The exports from the United States alone are substantial. In 2011, Americans disposed of about 130,000 computers and 300,000 cell phones every day. Unfortunately, Guiyu is not a lone story. A substantial amount of e-waste is being exported to other places in China, India, Ghana, Tanzania. For recycling, where labor costs are low and environmental regulations are not prevalent or not enforced. The toxic burden of the products we consume in the West has been shifted onto the world's most vulnerable in a systematic way. A number of companies have instituted high-profile hardware buyback or recycling programs where consumers can send their products back to the manufacturer for processing and reclamation. Although this is a clear positive environmental and marketing move, many of these same companies have also increased the amount of e-waste produced. Mandated changes to use lead-free solder has reduced the amount of harmful materials in electronic devices, but has caused design and reliability issues. These problems may be increasing the total amount of e-waste produced. Additionally, in the past 5 to 10 years, there's been a dramatic increase in the disposable electronics mentality. Product life cycles for phones, laptops, televisions, etc., have been reduced. The culture of early adoption forgoes environmental responsibility for the latest and greatest technologies. Manufacturers have fed into this culture of continuous change by designing obsolescence into their products. For example, changing their car charger plugs so that consumers will have to buy all new accessories. And 5G is coming.